these are the tools that we'll be looking at: Google Colab, Python, and these two Python libraries, Pandas and Matplotlib. And here's my email at the end of the presentation. If you need anything, if you have any follow-up questions afterwards, or something that you would like to discuss, and this is just my Twitter handle. Okay, so let's go into this back into the Google Drive. This should be in front of you now. What you can do, what you have here, you can only view it. You can't actually edit anything in here. So what you could do, you can just you can copy these files, make copies of them, and move them to somewhere on your drive that makes sense. Let's look at this first file here. This is just a brief. We're going to spend the first half of this presentation. I just want to give you an idea of what Collab is. It's basically a version of Jupyter Notebook, and then we'll give a brief introduction of what Python is and how it works. So I'm going to open this up. If you don't see this Collaboratory in your drive, if you don't see it, then you'll be able to open with, and you can add. You have to connect the app to your drive. So if you don't see this Google Collaboratory to open it up with, then you need to connect. You could click on here to connect the app so you can open it up. So this is what it looks like. This is the Google. This is the notebook that I designed. I'm just going to make this a little bit smaller here. So basically what we have here is a notebook with different cells. So if I double click on this one here, you'll see basically a space for me, or for me to develop my Python code. And there are two types of cells in these in Google Colab or in Jupyter Notebooks. One of them allows me to comment on what I'm coding, to actually write text. This is what this is. I've got a hashtag at the front of this text here, which then this is the only kind of to style what I'm writing, to make this into a header. So if I execute this, and I execute this by pressing Shift and Return, this is now the header of this notebook. If I double click on this, you can see I have text elements here, just normal text, and variants of titles. So if I use 2 hashtags, it's a smaller title, 3 hashtags, and so on. What I'm doing here is styling my text using markup, which you can find. Just a very simple, the simplest way to style your text, instead of using a Microsoft Word or whatever text editor you're using. So these are the text files. If you would like to look at all the markdown various ways to style your text, I've put in a link here. So you press on that, and it will take you down to all the different ways. So you're using hashtags for you can have lists if you just have dots or stars or asterisks and so on. But that's just a total sidetrack. The main thing for you is to remember that we've got 2 types of cells here, texts and ones for code. This one here, this is the other type of a cell. This is what we have in here. This is a code cell. But what I've done here is commented out what I've written. So I've put a hashtag in front of this, so the computer or the system doesn't read this as code, but as ignores it basically. But it helps us, if we're developing code, to actually then write in what we've done. Okay, so it actually, you've got this little arrow here, so I could run this. If I run it, you'll see this starts turning here. Basically, the first time you run it in Google Colab, it just takes a moment. Once you've done it once, once you've done it, things start speeding up. So you got here, we've got our cell with code in here. It's just actually everything's commented out, but we're ready to go now. And this is what we're going to look at. We're just going to do a print, an input. We're going to look at some data types. We're going to understand what actions are. We're going to look at variables, if, else, clauses, lists. And we're going to see what dictionaries are, assign track to tuples, look at functions and a for loop. It's a lot of stuff, but I would like you to just bear with me. You don't have to take it all in. I just want to run through this with you, just to give you a sense, because basically, if you understand all this, what we're going to do in the next step is basically just applying this, but applying these 10 features. Go into Python. What we have now, we're entering a code cell. This here is all commented out, so the computer doesn't read it as code. And this is the actual code we're writing. We're printing out, and we put it in brackets, this phrase "hello world." So we run that, and we said then the result is nicely it's printed out. The second function we're going to look at is the input. So now we won't just print it out, it will ask us to interact with it. So we do that. We need to put in our age. I'm going to put in my age, and then we get the result brought back. That was just printed out straight out. Here we need to interact, and it's just then printed out. So part of inbuilt into the input function somewhere will also be a printout, so it actually prints it out. You don't see it here because that's built into what this function does. Okay, so simple first step, print input. Now let's go into this. Now we're entering something the very important area, namely the data types. And if you understand this, you'll understand a lot of what comes next. Strings. Strings is text, basically. Computers can actually only read numbers, but they have a complicated sequences of numbers that are then understood as text. So basically what the computer, anything that's in inverted commas, be there single or double, the computer reads as text. And nicely enough, you'll see it goes red. Every time you have a string, Google Colab will mark that as red. So you understand that it's the computer reads it as a string. So then if I run that, it prints out this string. Hello, how are you? The second type of numbers of data types are numbers. So if I just write in 1, 2, 3, and you see this has turned slightly blue, this is the second type of the data types, and these are integers, numbers, full numbers. So if I write, I've got this nice function here to see what type of data is this type, and again you'll see the syntax, put them in brackets. If I run this, this is telling me, oh, this is an integer. I can also change things if I want to. If I've got this number here, this 1, 2, 4, which is obviously an integer, but I can also change that into a string. If I run that, then you'll see what I get back is 1, 2, 3, but they are in inverted commas. The computers change that into a string. So we've got strings and we have integers. The first two very important data types that the computer reads, and the third one are so-called floats, which are decimal numbers. So 4.542323, that is a float. I can transform integers into floats, and then in this case, it will just return .0 because it just puts a .0 on the end. And I can also change integers into change floats into integers. What it does here, it doesn't round the numbers. What it does, it just cuts off the decimal numbers. So 4.64 will change into 4. So so we have strings, that's text data. We have integers and floats, which are numbers, and the final important type of data. They are actually read as strings, but strings with a specific format, dates. So 15th of November, 2019. They are written also in inverted commas. You can also you can have single ones, as I mentioned. You can also have double ones. I'm going to put the double ones in here now. So if I run that, the computer just reads that as a string. But it's a string with a certain format, so it's something that we can work with, and we'll be getting back to this when we work with the COVID data. We can start combining strings. There are two ways to combine strings. We can either just put a comma in between the strings that we're going to combine, or we can work with the plus sign. As you see, if I use the comma, it automatically introduces an empty space in between hello and four and students. If I want this empty space when I'm using the plus, then I will need to introduce it myself. Just a small thing that whoever came up with, whoever developed Python at this stage created. So you see, if I haven't put it there, how are you is all written in one word. And then, of course, you have the simple minus and plus, multiply, divider, modulo, which basically you divide two numbers and it gives you the leftovers. So in this case, 22 divided by 5 and 2 would be the modulo, which you use the percent sign for. And then you have power of, so 2 times 2 times 2 and so on. And you're using the two asterisks, not just one for that. Very simple stuff. We all had that at school. Sometime might have been a while ago, was for me, but yeah, it's pretty straightforward. And obviously the only we can only use commas and pluses with strings. When we're dealing with numbers, we can obviously use all these different ways of adding up and dividing. That goes without speaking. Okay, so we've got the data types. We have our first simple functions, print and input, and now we can actually start manipulating the data we have using these simple actions. Now let's move on to variables and comparisons. Very important, and this is basically why Python works so nicely, is the simple way to create variables, and not to be mistaken with comparisons you can draw. So basically here we have what I'm doing here. I've got, as you can see, I've got two equal signs. So what I'm doing here is comparing Switzerland with two strings that are absolutely identical. So what it does, it returns true. Yes, the comparison that I'm making, that is true. Now, if I do the same thing with Switzerland is Georgia, obviously that is not going to, that is not true. Two very different strings here, and it returns false. Now, if I only use one, what I'm doing here is that I'm creating a variable. I'm creating the computer from now on, from this step onwards, the computer will read Switzerland as rich, as a string, as identical with the string rich. So if I run that, replace that, and if I just run Switzerland, then it returns rich, because I've just created that variable. From now on, Switzerland, until I've decided something else, that is what Switzerland is in this world I'm creating. Now, if I do the same thing, what I'm doing here, I'm no longer assigning rich to Switzerland, but I'm comparing it. And Switzerland is rich. If I compare it to rich, then yes, this is true. That is true. And I can play around with this. What you can't do is you can't assign a variable cannot be a string. As you see here, number 1, I've got as a string, and what I'm trying to do is make that into a variable. But that is already assigned. The system already needs that 1 as a string. It's already assigned. So you can't assign it with something else. You can only actually create variables out of new elements, which are then they have to be either letters from the alphabet to create that. You can also not use reassign number 1, make it number 6. That also doesn't work. You can see then that it gives you this a syntax error, can't assign to literal. A literal, that's basically something that Python cannot change, because if it starts changing that, then it'd be very difficult to work with. Yeah, but you can, of course, anything as a letter or anything after. I could do if I start my variable with a letter, I can afterwards use numbers, and you'll see this won't change. This will stay black. But if I start my variable with a number, then it doesn't know what to do, and it goes a color, which means I can't assign 34 to 1A, but it works with A1. It's just a simple detail to remember. It could really mess you up if you don't understand that. So, but that's basically we can make a variable out of anything. The nice thing about Google Colab is these little arrows here as well. So I'm going to click in these things that we've done. We've gone over print and input. We've gone over data types. We've gone over some actions. We now know what variables are. We're comparing this. We can compare strings and numbers and variables. What we have left is the if and else clause, the lists, dictionaries, tuples, and a for loop. Okay, so we're moving on to the if else. What if else is? This is something that the concept, I'm sure most of you have heard of, if you haven't programmed yourself. Basically, if something happens, please do something else. So what we're already starting to combine things now. Basically, I'm asking the user to tell me how old they are, and I'm also changing it into an integer, into a number, and I'm saving this off as a variable, and this variable is called lm. Could be anything. I could call it anything I want. So if I run this, the computer will ask me, okay, how old are you? I'm going to put in 46. When I run this variable here, the computer you will see the number 46 is assigned to this variable. So I've created my variable by interacting with a user. I can now type is that's an integer. Of course, it's an integer because I made it an integer up here. And now I can start interacting using this information to interact with whoever has put in this information. So if I say, okay, if the element that was put in is smaller than 0, that is important. I'm going to tell the output will be that is impossible. If it is possible, then then the computer will say you are old. So if I run this now, then remember lm is 46. It's not smaller than 0, so it's not going to take this. It's going to go on to this solution. It's going to say the output will be you are old. Now I can, of course, just extend that, and this is where this if comes into play. Because if I want, I can now create different buckets or different answers depending on what the user entered, depending on what this element, this variable is. So if I run this, it's going to tell me, oh, there's a mistake here somewhere. As you see, it tells me here, very nicely, I've forgotten an inverted comma up here. And as soon as I do that, it doesn't know where the string ends. So it tells me there's a mistake. I'll run this again. I have to give him a number first. Let's say I'm 35, and it will tell me you are very old, because it's not, because 35 is not smaller than 35. So it jumps onto you are very old. If it was older than 46, it would tell me you are ancient. So basically, that's in a nutshell how the if, elif, else clause works. And you can imagine you could create a huge tree out of all the different possibilities. This now, just some of you might be thinking, why are we looking at this? Where's the relation to actually using this with our everyday work with data? Well, of course, I mean, you could create a function that reacts to data in a huge spreadsheet, depending on, you could create a very intricate and extended if, elif, else clause to clean the data, or to put into a format that you can then actually work with and visualize. Okay, so that was the if, else clause. Now, two more data types, or collections of data types that you really need to understand, the so-called lists. Lists are, in Python, just, as it says, lists of entities. They can be integers, they can be strings, and they are always start with this weird bracket here, and end in this bracket. On the Mac, it's you can find these when you on the keyboard that I'm using, which is a German one, using Alt 5 and Alt 6. On your keyboard, whichever language you're using, it might be slightly different, but they are there. It will be one of the, sometimes I think on the English one is actually, they're actually written, they're actually on the keys, so you shouldn't have any problem finding them. So this is a list. It consists out of 1, 2, 3, 4, 5, 6, 7 elements, and it has integers, it has strings, and it also has float. It has one float. So when I run that, what I get, I just get the return of the list. Now I can also make a list. The list also exists as a function. If I use this list and I run it over Tbilisi, I've written it wrongly. What it does, it sections the string into, it divides each letter into its own string. So I have a list of letters. Nothing, just to give you an idea that we're actually starting to manipulate data and text here already. So, and I can also make, and I can also have variables consisting of a list. So if I run that, now, just taking a moment. So now when this LST, I'm obviously not allowed to use the LST here because that's a function in itself. If I use that, then I'm overwriting this function, which I don't want to do. So I'm just writing list without an I. So LST, this is my variable now, and this variable is a list consisting of 7 elements. And in this case, it's seven integers. Now I can start pinpointing the elements of this list I want. And this is where it gets really exciting. And you can imagine when you have a huge amount of data, these are the things that come in handy. This is where it gets, where Python starts developing its full power. So what I'm doing here, I'm just picking the first element of the list. So LST, then these 30 brackets and 0. Now 0 is, for a computer, that's always the first element of a list. So 0 is the first, not number 1, but 0 is the first element of the list. So if I run that, okay, we got 1. If I do this, if I want the second element of the list, I need to put in 1, and I run that. Now I can also choose segments of a list. I'm telling him I want the 0, from the very first element of the list up until the 5th one, but not including the 5th one. So that's 1, 2, 3, 4, 5 elements are come. Not the 5th is obviously the 6th element. So up to the 6th element. So he is this is what I've picked. I've cut off the last two elements, and I can also do very complicated things. I can say I want to skip every other element. As you see, this element is 1, 2, 3, 4, 5, 6, 7. That's the list. If I put in these two semicolons, and then say 2, give him the number 2, which means he will jump over every other one. So there's suddenly number 2 and the number 4 and the number 6 are cut out, and that's the list it returns. And I can also start cutting off bits and pieces. I can say with this here dot pop, I can cut off the end of the list, which is the number 7. So if I run that, the number 7 disappears. If I look at my list again now, you will see that number 7 is gone because I just popped it off and it's gone for good. I could also save that. In this case now, it will be number 6. So I'll pop it off, but I will at the same time, I will save it off as it will be within this variable then. So if I do that, and then I will now look at that. Look at this variable here, saved item. This is the number 6. Now I'm going to put this with dot append. I'm going to, as you see, got the brackets, and I'm going to append. So stick the number 6 back on the end of the list. So when I look at this list, I'll have the number 1, 2, 3, 4, 5, 6. Okay. We did that with the splitting up strings. We won't go into any more detail here. What I'm doing here, I'm creating, and this is the last bit of the list that we'll be looking at. I'm creating a range. So I'm telling him, make a list out of numbers that range from 10 up until, but not including 15. We could do it up to 100 maybe. Make it to give a bit of a higher number. So range 10, 100. So this will now create a list from a range from 10 up to 100, so up to 99. If I run that here, this is a little bit longer. So this goes all the way down to 99. I could also go backwards if I use these minuses and so on. And then at the end, of course, I can also create a variable out of this list that I've made. Okay. So that was lists. Lists that we can consist of, they've got those weird brackets, and they can consist of any data type the computer can read. They're just separated by commas. I will close this element again. We've been through the print and input, the 3 with dates, most important, the 4 most important data types. We've been through a few actions. We know what variables are. So we can create variables. We know what if else is. Lists. Now we've got 3 more things to look at before we then take a large step and start playing around with the COVID data. Dictionaries. Dictionaries are basically spreadsheets. If I want to put it as simply as possible, dictionaries are basically spreadsheets. Let's look at this. What I have here, introducing another weird bracket, these curvy brackets. On my keyboard, they are Alt 8 and 9. You'll have to see where they are on yours. Depending on the language you're using, they will be in a different place, like the other brackets we just looked at with lists. But what we have here, this is a dictionary element. And you could look at this as the header of a spreadsheet. So the header would be animal, size, and age. And the first row would be dog, size 124, age 10. Okay, so that will be one element in this of the header and the first row of a spreadsheet. this is the so-called key, the dictionary key, and this is the dictionary value. And you'll see that they are separated by these semicolons and by commas. So you have animal, semicolon, dog, that's the first key and value of the dictionary, size 124, age, and 10. And they're all separated exactly the same. That's the structure of a dictionary. It's very similar to what you will see if some people have ever seen JSON data. It's a very similar format. And that's also one of the reasons why Python is such a nice language to interact with APIs and APIs and start playing around with data, because the JSON, which is very often the format that you'll find when you're querying APIs, is so similar to dictionaries. Now, what I'm doing here, I'm assigning this animal dog size to the variable animal, and then I'm calling that variable, and it gives me exactly, obviously, what I've just assigned it with. And I could now start, I could say, look, all I want to know is the animal's color. So and this is when to get this information, I can target this key using these brackets again. It has nothing to do with the brackets that we use for lists, but I'm using this animal and these brackets to target this specific color of this one dictionary. Okay, is that clear? And I could do that with anyone. Now, it's not that interesting if you just have one dictionary entry. It starts getting interesting if we now combine the data type, the list, and make a list of dictionaries. And what I've done here, I've made a small list. This list consists of 2 elements, dictionary elements. So we have animal, dog, size 124, age 10, color brown, comma, and now the next element comes, the next element in the list, animal, cat, size 10, age 8, color black. So we have a list here consisting of 2 elements. And basically what that would be in your spreadsheet, that would be, so you would have the header would be animal, size, age, color. And then you would have 2 rows with the dog, 124, 10, brown, and cat, 108, black. That's all there is to it. If you get that and understand that, that's basically what dictionaries are. They're basically spreadsheets, but just easier to read for the computer. So if I read that in, and if I call this type, type, that's a list, nice. And then I can start, and I can say, okay, give me the first element of this list, and it will then pull out the first dictionary element, including all the keys and all the values. And then I can say, okay, give me the first element of the list, but just the age. So you can really start pinpointing what you want. And that's why it's so nice to work with in an API. The final data type, and we'll move on to the final bit, then the for loop, the final data type, just to round things off. You don't really find this type of that much, is so-called tuples, and they are basically work exactly the same as lists, just it's not these funny cornered brackets, but it's actually the ones with the rounded brackets. That's all. And the only difference to a list is that the sequence is not changeable. You cannot, tuples are fixed, it's like a kind of like a stamp. You can't change the sequence of the contents of a tuple, which is handy for some situations, but when you're manipulating data, very often not. So you don't really work with that often. But I just wanted to give it because we then really have covered all data types and contents of data. Okay, the final step is for loops. This is when this is basically to do the repetitive, getting the computer to do the repetitive, boring work. And to understand how that works, we're going to develop these for loops. What we're doing here, we're creating a list. We've got this list that has got 6 elements in. We did that before. And now what we're going to do, we're going to print out every element of this list. So, and then the way we do that, the syntax for this is for element lm in list. This can be, you can name this and whatever you want, any name. You just have to repeat it down here because it will go down. My computer seems to be slowing down. Any name. It will take any, or let's call it any number, just to make it perfectly clear what we're doing here. So it will go in, take the first number and print that out. Then it will go in, second number, print it out, third number, fourth number, fifth number, sixth number, and print it out. So we do that and it just prints out these 6 numbers. Now, obviously, we could say, okay, start. We don't want you just to print it out. We want you to do something with this. So what I'm doing here now, I'm creating a new list which is empty, and I'm going into this list here that I've got. And I'm saying if it's divisible by 2 with 0 leftovers, then add it to this new list. If it's divisible by 3, I won't do anything. So if I run that, and then I look at my new list, 2, 3, 4, 6 came along, but number 1 and 5, because they didn't meet our terms, didn't. But that's just a really small kind of excerpt into this. We're really starting to really maul and play with the data here now. But just to give you an idea of how that works, I'll summarize, and then we're going to move on to the big data set and using Pandas with this, which is an open source development based on Python, based on all these bits and pieces that we've gone through now, to actually work with this larger data set. Okay, as a summary, what we've done, print and input, we looked at the data types, integers, floats, and strings, and dates, actions. We can create variables. We looked at the if-else clause. We know what lists are. We know what dictionaries are, namely basically spreadsheets. We had a quick look at tuples, and we looked at for loops. They are the building blocks of any programming language, basically. Now, if we go back to the drive here, let's open up this second workbook. We're now moving on to the COVID data. Takes a little while for it to open. Now, what you will see here at the beginning, at the introduction of this file, of course, it is another code cell, as you will see. Various imports. You've got import pandas, import matplotlib, import numpy, import matplotlib, this weird percentage sign and matplotlib inline, and then this from Google.Colab import files. What these are functions and developments and libraries that other people have developed, and we can now use because they're totally open source. We know how to use them because we know how to use Python. It's very powerful, especially all these things here, pandas and matplotlib and numpy and so on. You can Google them if you want to know how they work. When you start getting to know a library, using a library, always a good idea to spend a lot of time with the actual documentation, just to see what are the most important functions. And basically, once you do start using something like Pandas, which is it's vast now. There were dozens of people working on this and developing it, and it's on its about 30th or 50th iteration now, and it's constantly developing and evolving. It's always a good idea, and it's always to look at latest features. And when you want to do something, you just Google it, and you'll find it on somewhere in places like Stack Overflow. People who have had a similar problem to what you're trying to solve, and you can just basically copy paste it and use it. So all these things here, if you want to know more about them, Pandas, Matplotlib, NumPy, or Google Colab, Google it. And find the documentation. Pandas, very simple documentation here, and you'll find this is you'll find the whole list of yeah, even nice tutorials and so on. Great Pandas documentation is especially well done. A quick hark back to what we did before, this dictionary list we created. Remember, I said it was basically a spreadsheet with 2 rows. So I'm going to feed this in, and I've got my dictionary underscore list, which is the variable I created. Now what I'm doing is I'm pulling this pandas PD, which is this pandas, this statistical tool, which is developed in Python, and then data frame with a capital D and a capital F. If you hover over it, you can actually see much more details on how it works and what we're actually doing here. But I'm going to now call this, and you'll see that this dictionary list now changes into something that looks much more familiar to us. Basically, what we have here now, it's reading it and it's changed it into a spreadsheet using the keys as the header and so on. For us, it's much more consumable. And what it's also done is got an index here, which it's created. Just assume that that's the number 0 in the index and that's the number 1 and so on. So now what we're doing now in this next step, this is a big leap now. What we're doing now, we're pulling in the data set that I mentioned before, this Our World in data set. As you see, it's the raw data.csv, that stands for comma separated value. So we're pulling in this data here, reading it, and we're saving it off in this variable df. That's the name, data frame. That's what we're calling it. This will take a moment because it's a big data set. You'll see it's loading here. So we're putting it off wherever Our World as data has saved it off, and has collected this data, and we're saving it off in this variable here. So the entire data set is now within this variable. In Pandas, I've got this nice function to look at to give me a summary of what I've got in this data set. So, and that's I can access just by putting this .info and then brackets. If I run that, then I'll see, this is starting to get a bit more interesting now. So I have 54,363 entries and 50 columns. And I have things like ISO code, the continent, the location, and so on, new deaths, total cases per million, ICU patients, and so on. As a lot of information I have back here. I have how many cells, how many rows are actually filled with content. You'll see that not all of them are. I have a total of 54,363 entries, but the ISO code, I've got some missing ones, about 300 missing ones, some missing continents, not all the countries are reporting the deaths, and so on. So that's more on the actual content, that's more on the rows. And then back here I have information on what the type of data it is. An object is basically a string. You can read it as a string, and a float we've heard about before, decimal numbers. 64 basically just implies that it can decimal numbers with 64. A lot of information here already. You can already see if we opened up this if you open this up in a spreadsheet, it will be with 54,000 rows, very difficult to read, difficult to start playing around with. Just the pure size of it is difficult to handle in a spreadsheet. It's possible, but it's getting difficult already. Now what we're going to do, we got this date, and we want to make sure the computer reads it as a date. So what we have here is we're making sure that the computer transforms it into a date format. In here we have let's look at the first 5 rows just to give us a bit more feel of this data. df, and I'm looking at head, and then I'm saying head gives us the first 5 rows. So, okay, we have the ISO code, continent, location, date, 24th of February, 2020. If I scroll over here to the right, I can see all the other rows that we have that we could look at. Not difficult to look at in like this. That's why, just to give us an idea what the data is actually in real life looks like. So what we're going to do, we're going to take this date here. We're going to format it, reformat it, have it day, month, year, and we're going to actually make sure that the computer reads it as a date, not just as a string. And we're going to make that date we're going to replace this number here, make the date into the index of our file. So doing this 58,000 times, you can see just done, already done now. Nice, nice. We're going to run that again, and now we can see, okay. So now this file runs from the 24th of February, 2020 till yesterday. That's when the last update of this data set was. So the 15th of December, 2020. Okay, so we've got a nice summary of the day of this. Now, basically, what we're going to do is very simply visualize the new cases rates in each country, but we'll pick some countries, and obviously we'll look at Georgia and compare it to some larger countries just to see. And obviously you will know that in terms of new cases, Georgia is not doing great at the moment, like Switzerland, by the way. It's not a great prospect at the moment. But let's look at, first of all, we're going to look at Georgia. So we have here, this is basically just the syntax to access the data on Georgia. What I'm telling it to do is data frame, take the location, and wherever it's similar, remember those 2 equal signs that we looked at when we were comparing things, wherever the location equals Georgia, pull that out. And so if we run this now, this is just showing all the 294 rows it has on Georgia. This alone will be so we're cutting everything else out and just looking at the Georgian data. So basically we're filtering something. Also you could do with a spreadsheet, but when you need to do this every day, and it's so the data sets are growing, it becomes so much easier when you do this with Python. What we're going to do now is we're just going to choose some data that's interesting for us. We're going to take the date, and we're going to take the location. New cases, we don't want it all, so we're going to do new cases smooth. So we're just picking a section of the data for us to work with, because maybe we just don't want to work with all those different total deaths and ICU beds. We're just interested in certain things. That's what I'm doing with this copy here. Just look at the syntax. Basically, I've got the list of title of headers, and this is just a Pandas specific syntax to pull out what I'm actually interested in, copying that here and creating a new data frame, which I'm just calling DFF, just because I couldn't think of a better name. So this is the DFF. This is the one what I'm working with now. And here I'm going back to Georgia, and I'm saying, okay, show me all the new cases, smooth, which is the 7-day rolling average of cases. And I'm just putting at the end, and this is where I'm bringing in a new library, namely the Matplotlib library that we imported at the beginning. I'm saying, please plot that. And when I run that, I see the curve of Georgia. Luckily, we have a steep decline now, but we see the exponential growth for a while of new cases of the coronavirus in Georgia. Now let's compare that to, let's bring in some other countries. There are different ways to do this, obviously, but I'm choosing the simplest way. I'm just pulling in countries. I've got Italy, I've got Germany, United Kingdom, United States, and Georgia. The colors are just randomly assigned. I've written them back here just so you know which ones they are. But you can also define the colors, of course. That's no issue. We won't go into the details here. If I run this, you have an overview of the development of cases in Italy, Germany, United Kingdom, United States, and Georgia. Obviously here, Georgia doesn't look as bad, and United States looks terrible, but this is obviously because of this, down to the size of the country. The States have by far is the biggest of these countries, therefore they will have the most cases. It's not great what's happening, but if you then look at the data and the new cases smooth per million, the picture is totally different, doing exactly the same thing, just bringing in the same countries. New cases smooth per million, hammering this dot plot at the end. And here you'll see that in comparison, Georgia has, compared to these larger nations, has had by far the worst second wave when it comes to maybe the US. You can consider it's the third wave. They had one in the summer, but Georgia now in the winter has had the worst second wave. And I'm just playing around with this now, and this large data set, by just picking out bits, the countries that I want, the parameters I want to compare. Simple line graph now, but obviously there are much more different types of graphs you can do. If you want to know more about Matplotlib, go to the documentation. Very nice, also very nicely documented with tutorials and with a nice example section of all the different types. And this again is also expanding just incredible amount of graphs and types of graphs that you can use and implement. Exactly. Okay, and this you can just go on and explore basically what you're doing here with very simple means. You can create your own very personalized, very flexible dashboard of COVID data, and obviously any data set that's continuously updated. And this is the last step. You can download what I've done here. I've just created the legend corresponding to the color, and the last step is you can download. Obviously, just doesn't have to just stay within your Google Colab environment. You can download the data, or even the SVG, or the visuals that you've created. You can download onto your computer to work with further. If what you've done here is not enough, when it comes to styling, you would obviously want to restyle this maybe a bit. You can do a bit of styling with Matplotlib itself. There are a lot of parameters to change the colors, to work on the titles, to work on the ticks, and so on, and whatever you want to do. And you just download that, and then maybe refine the styling a bit. Or if you just download the raw data to work with some other visualization tool, but you just want to use this as your data refinement area, which is something that I do mostly. I don't actually then work with visuals that I have here, but I work to refine the data and then transfer it to some other space where I then actually visualize it. So that's basically the final step. So if I run this, you'll see down here, it's downloading my the last data set here, the DFF that I defined. And down here is my example CSV, which I can then open up in a spreadsheet if I want to, or in Google Sheets, when I've then really pinpointed and created what I wanted.